Given that you have already learned how you can solve definite integrals, and if you haven't, I suggest you checking out the previous video on this channel. So by now you should know that you can use integration to solve for an area under the curve. Let's say we have a curve f of x drawn like this. You have a curve drawn like this, and this is f of x. Let's say we want to solve from 0 all the way up to 0.5. We want to solve this area. What we can do is to take the integral bottom limit 0 to 5 of f of x dx, and you will get the area under the curve. However, there's always a concept that we need to understand. Is, let's say x, and this is g of x. We have a curve drawn like this, and this is our g of x. And then you want to find the area from 0 all the way up to, let's say this is 10, right? And you kind of want to find the area here, here, and here. Unfortunately, since we have two functions here, what two functions? Our first function is g of x, and our second function is basically y equals to 0, right? This line right here is y equals to 0, right? So y equals to 0. So in this case, we have this positive area. No, let's not call it positive area, but let's call it, we have this area here, where highlight this area here, where g of x is above y equals to 0, and this area here where g of x is above y equals 0. Well, the area under here is where y equals to 0 is above g of x. So one concept we always have to understand is that we always take the integral of the, if we want to find the total area is always equal to the integral of the upper, obviously we have the lower limit to the upper limit of the upper function minus the lower function dx, right? This means, in this case, what we need to do is we have to solve to find these two areas, the area highlighted under blue, these two areas. We actually have to use, let's say this is 3 and this is 5. So we have to actually solve integral from 0 to 3 of g of x dx plus our integral from 3 to 5 of negative g of x dx, because 0, y equals 0 minus g of x, negative g of x dx, and then we have to plus from 5 to 10 g of x dx again, and this will get total area. This is a very important concept to understand if you want to solve the area under a curve, especially when it comes to curves where there are two or more functions, right? So let us move into a practice question, and after that we'll try to develop our sense for how do we solve this such question. So our first question. Right, figure 2 shows the line with equation y equals 10 minus x and the equation curve with the equation y equals 10x minus x squared minus 8. F of x equal to 10 minus x and g of x equal to 10x minus x squared minus 8. Right? The line and the curve intersect at point A and B, and O is the origin. Calculate the coordinates of A and the coordinates of B. Right. So for question 4, now let us start. coordinates of A and coordinates of B. How do we find this, right? So you will find that these are the points where they intersect, and therefore this is the point where g of x should be equal to f of x, and therefore 10x minus x squared minus 8 equal to 10 minus x. And when you bring all of it into the one side, 10x minus x squared minus 8 minus 10 plus x equals to 0. Simplify it and you get 9x, 11x minus x squared negative 18 equals to 0. And of course you can just put this in your calculator, or you can use the quadratic formula and you'll find that x is equal to 2 or x is equal to 9. Therefore, you will find that here this part is 2 and this part is 9. Right, now you know the upper lower limits, right? So you can solve for b. In this case, okay, the shaded area R is bounded by the line and the curve as shown in figure 2. Calculate the exact area of R. Well, so in this case, we see that 2 to 9 upper function is always equal to, the upper function is our g of x. Because throughout, our g of x is above this f of x. Right? So our upper function, we get 2 to 9 upper function minus lower function dx, right? And there you will get our lower function is f of x. When you zoom out, so we get integral from 2 to 9, upper function is 10x minus x squared minus 8 minus 10 minus x. Always remember to leave your answer in brackets because you don't want to mix up the signs. So simplify, we get 2 to 9, 10x minus x squared minus 8 minus 10 plus x dx. 2 to 9, 11x minus x squared minus 18 dx. And of course, continue over here and you will get 11x squared divided by 2 minus x cubed divided by 3 minus 18x, and it will be bounded by 2 to 9. Substitute. What you want to do is you want to substitute 9 in first, so 11 9 squared divided by 2 minus 9 cubed divided by 3 minus 18 multiplied by 9 minus 11 2 squared divided by 2 minus 2 cubed divided by 3 minus 18 multiplied by 2 by 343 over 6. Moving on now into a more complex question where we have to figure out the graph on our own. So right, find the area bounded by f of x equal to x squared plus 1 and y equals 0 for negative 1 to for x negative 1 to 3. This one is pretty simple, right? Since we can estimate the graph, let this be y and this be x, right? We want to find the area from negative 1 to 3. And we have two functions here, x squared plus 1. Now we know that f of x equals x squared plus 1. We know that it's definitely a curve with an asymptote because it has a square, so it's definitely a maximum or minimum. And how you can find is to you differentiate it, you get 2x. When x equals 0, slope equals 0, or you can say dy dx equals 0, and you can also use the second derivative that d2y dx squared equals 2, and it's more than 0, therefore it is a minimum, and therefore it will be this one. And another thing you can find is where the asymptote is. So when x is 0, we include here. When f is 0, you get 1. and therefore y equals 1. So 0, 1, right? So you will find 0, 1. And therefore you will have this curve. We can draw the curve here. Always remember when you're solving integration questions that involve that where they don't give you the graph, you have to draw it out yourself to find the total area. Otherwise, you end up making huge mistakes. That's why I always suggest you draw the graph first. So the graph approximately looks like this. So, and y equals to 0, that means y equals to 0 is just this area. It's here. It's this. Right? So, what we want to find is the area from -1 to 3. Now, let me extend. I know this looks bad, but just make do of what I can. So basically, you are trying to find this area here, right? So you will see throughout from -1 to 3, -1 to 3, throughout from -1 to 3, the upper function is always equal to our f of x here. Upper function always equal to f of x here, and our lower function is always equal to y equal to 0 is always the lower function. So therefore, in order to solve the question, remember the upper function minus lower function, right? So we get x squared plus 1 minus 0 dx, right? Equal to x cubed over 3 plus x from 3 to -1, and you will get, just substitute in, right? 3 cubed over 3 plus 3 minus -1 cubed over 3 plus -1, and you will get, always be careful of the symbols, the negative symbols especially, get 40 over 3, and that is your total area from under curve from -1 to 3. Now moving on, right? Find the area between the graph f of x equals x squared minus 9 and the y-axis over indicated interval from a, okay, a 0 to 2 and b 2 to 4. First of all, always remember, draw the graph, right? Always draw the graph. You can have a rough sketch, and that should be it, right? So f of x equal to x squared minus 9. Now, of course, when we differentiate it, we get 2x, right? And of course, when we differentiate it for the second time, second derivative, you get 2, which is more than 0, and therefore it's the minimum, and the curve will look like this. Now, when x equals to 0, y f 0 equal to -9. So our point will always be 0, -9. Therefore, our curve will most probably look like this. Let me extend this part. -9. Our curve will most likely look like this. Our curve will most probably look like this. Now, we want to know what are the x-intercepts, right? If you want to know what the x-intercepts are, we need to substitute our, wait, let me find f of x minus 9. To find our x-intercept, we have to let our y equal to 0. To find our x-intercepts here, x1 and x2, we have to let to find x1 and x2, let f of x equal to 0, and therefore you get x squared minus 9 equal to 0, and you will find that x equal to 9, x squared equal to 9, x equal to plus minus square root of 9 equal to plus equal to 3 or -3. So you will find that this x -1 is -3, and here is 3, right? So now we have actually found what we needed. Now, what area do we want? Right? So for part A, we got 0 to 2, 0 to 2. We want to find this area. Let me use a different color. I want to find area. For A, this area, right? So 0 to 2. You will always notice the upper function is y equal to 0 and the lower function is our f of x. So in this case, for question A, our upper function equal to y equal to 0 and our lower function is x squared minus 9, which is our f of x. Right? So, because our y equals 0 is always above our f of x in this interval. So we will solve from 0 to 2. Upper function 0 minus x squared minus 9 dx. Simplify. Be careful of the signs, right? Negative x squared plus 9 dx. And you will get negative x cubed over 3 plus 9x from the interval 0 to 2. And you will solve this, you will get 46 over 3. And this is your total area from interval 0 to 2. Now, for the next part, we want to solve from 2 to 4, right? This area 4. So we want to solve the area from 2 to 4. So it's basically what we are doing. We are actually going to solve from 2 to 4. Right? And you will see in this part, our upper function is going to be y equals 0. And in this part, our upper function is going to be the f of x. Right? So what we want to do, okay. Now let me use another color. Let me label this part as B1 and this part as B2. So area for B1, so to solve for B, now let me move all the extra workings we have aside. Right, so we have more space. Right, to solve for B, we need to take B1, area B1, plus our area B2. So our B1 area is equal to integral from 2 to 3, upper function minus lower function, which is 0, in this case, 0 minus our f of x squared minus 9 dx. You will get 2 to 3 negative x squared plus 9 dx. And I'm going to save space here, but I'm going to just type in my answer, 8 over 3, and our area B2 is equal to the integral from 3 to 4, which is area 3 to 4, where our upper function is x squared minus 9 minus 0 d of x, which is basically 3 or 4. 3 to 4 x squared minus 9 dx is equal to x power 3 over 3 minus 9x and 3 to 4, and your answer will be, and you get 10 to 3. So as a total, you get B, we have to take 8 over 3 plus 10 over 3, and you get, and that will be your area under the curve for B. Now, moving on. Find the area bounded by f of x equal to x squared minus 1 g of x equal half of x, negative half of x minus 3, x equals negative 1 and x equals negative 2. What we want to do is to draw out the graph first, and always let us draw the graph first. Label this as y, label this as x. F of x equals x squared minus 1. Let us solve for f of x, right? Let us use different colors, right? F of x equals to x squared minus 1 dy dx, get to x, when x equals 0, slope equals 0, when x equals 0, y equals to negative 1. Therefore, our slope is 0, negative 1, right? Second differentiation is 2 smaller than 0, and therefore it is minimum. So it's a U-shaped curve, right? Our minimum point will be at 0, negative 1. 0, negative 1. 1. This will be our minimum point. And what we want to do is to find our x-intercepts for f of x, right? So let x squared minus 1 equals to 0. We will take our x-intercepts are plus minus square root of 1, negative square root of 1, and this is square root of 1. And now we want to do the same for our g of x, right? Because g of x equals to negative half of x minus 3. And therefore, this means that given on y equals mx plus c, where m is the gradient or slope, and c is the y-intercept, our graph intersects at negative 3. Y equals negative 3. A negative slope is definitely going to look like this. Y-intercept, so y-intercept at negative 3. And therefore, our slope aligns of this. And therefore, what we want to do is to find the area between negative x equals negative 1, negative 1. Let me use a different color again. X equals to negative 1, and x equals to 2. Just trying to find this area. And what you will notice is throughout, our f of x is always the upper function, and g of x equals always is always the lower function. So, thankfully, in this case, all you have to do is to take the integral from negative 1 to 2. Let me make it smaller, negative 1 to 2. Upper function is x squared minus 1 minus our g of x, which is negative x minus 3 dx. And you will get negative 1 to 2 x squared minus 1 plus half of x plus 3 dx, and simplify it further, negative 1 2 x squared plus half of x plus 2 dx. And you get x power 3 plus 1/4 of x squared plus 2x from negative 1 to 2, and just input that into your calculator and you'll get 39/4, and this will be your total area under the curve. Moving on, find the area bounded by f of x equals to 6 minus x squared and g of x equal to x. Right. First of all, let us draw the graph again. Right, our f of x x minus x squared dy dx, our differentiation is negative 2x. When x equals 0, our f of x y equal to 6. And therefore, this will be our turning point. When we differentiate the second time, second derivative dx squared, we get negative 2. And this is less than 0, therefore this means that in a maximum. So it will look something like this, like n, upside down u, right? So our turning point is 0, 0, 6, right? So we get 0 to x equal to 0 and y equal to 6. So our curve most likely looks something like this. Now, in order to find our x-intercepts here and here, what we need to do is to actually let y equal to 0, and therefore 0 equals 6 minus x squared, and what we get x squared equal to 6, and therefore this leads to our x having equal to square root plus negative square root of 6, or x equal to square root of 6, negative square root of 6, and this is square root of 6, right? And also, our g of x equal to x. This one is simple, right? Thank goodness we don't need to do much calculation here. This is just a slope of 1, right? G of x, right? And this is our f of x. Okay, now we kind of want to know, okay, here's the thing, the area bounded between these two, right? So what we want to find the area, this whole area, you know? And what you will notice is we need to know our upper and lower limits, right? So what is x2 and this is x1? We let our f of x equal g of x because they intercept at that point, right? So let f of x equal g of x, and that means that our 6 minus x squared equals to g of x is x. Bring all over to one side, you get 6 minus x squared minus x equals 0, right? And use the quadratic formula or just type into your calculator. You will get x equals 2, or n, or we can say n, x equal to negative 3. And that means that our point here is negative 3 and here is 2. So we have set our upper and lower limits, right? And after that, we always know that throughout this whole area under the curve, our f of x is above. It's always above. It's always above our g of x. So we don't need to have a worry about the sign diagram, right? So here's what we do. Calculate this area under the curve. Area, if we take the integral from negative 3 to 2, upper function, what is our upper function? F of x, right? So f of x is 6 minus x squared, then minus our lower function. What is our lower function? Our lower function is x, right? So we just minus x dx. And you get the answer 6 minus x squared, 6 minus x squared over x minus x squared x3 over 3, sorry, x squared over 2 from negative 3 2, and just input that into your calculator. I'm not going to do it step by step for you, but should be pretty easy at this point, right? You get 125 over 6, and that is your final answer. Right, moving on to the final question, right? Final question, guys. So, find the area bounded by f of x equal to 2x squared and g of x equal 4 minus 2x. First of all, as always, draw the graph. Draw the graph, guys. X and y. Right? So, f of x equal to 2x squared. Right? Differentiate it, and we get 4x. Right? And differentiate it again, and we get differentiate it again, and we get 4. And that is more than 0, therefore it's minimum. U-shaped curve, remember? Alright? And then when x is equal to 0, y equals to 0. That means our turning point is 0, 0, minimum. This is our minimum point. Right? So here, minimum point 0. So our curve f of x always will look like this. F of x. I want to extend it a bit. F of x curve, right? And our g of x, 4 minus 2x, okay, guys? So our g of x, obviously, g of x equals to 4 minus 2x. So using y minus mx equal mx plus c, we can rearrange g of x equal to negative 2x plus 4, and negative 2 is the slope, and that means sloping downwards, and 4 is y-intercept. And that means our graph will intercept at y equals to 4 and slope downwards. So most likely, this is how our graph will be looking like, right? For g of x. Right, so we want to find the area from negative 2 to 2. But first of all, before we really go into the depth of what is negative 2 to 2, we need to know our intercepts. What are our intercepts? Right? What? Use a different color. What are our intercepts here? x1 and x2. How do we find that? So how do we find that? Is using by letting the browsing the intercept, we let f of x equal to g of x, right? So we let f of x equal to g of x, and that means what we get is 2x squared equals to 4 minus 2x, and therefore what we get the equation, we get 2x squared minus 4 plus 2x equal to 0, and just use your quadratic equation, right? And 1 and x equal to negative 2. That means our points, I remember, will be from negative 2 to 1. However, if you look at the question, what are they asking? They're asking to find the area from negative 2 to 2. That means we are going to have to find, pardon my mistake, so we are going to find the area from here, not only here, but we're going to find this area here as well. So what you will notice that for this area, let me put it this way, for x equals negative 2 to x is actually 1, our upper function is going to be g of x, and our lower function is going to be f of x. However, from area from 1 to x equal to 4, 1 to x equal to 2, our upper function is going to be f of x. Here f of x is going to be more than g of x. F of x is going to be more than g of x. So L of x, lower function is g of x in this case. So we want to do two separate integrations, right? So how do we do this? Our first integration is going to take place from -2 to 1, right? For this area, for the first part, for this area, right? -2 to 1. And we take our upper function minus our lower function. But our upper function, g of x, right? So our 4 minus 2x minus our lower function minus 2 of x squared dx. Then we add together with our integration of 1 to 2, and we take our lower function. Upper function, which is f of x, 2x squared, minus our lower function, minus 4 minus 2x dx. And now let me solve this for you, right? We're going to bring this. Okay, let me just make this smaller, right? I'm running out of space. So we get 4. Let's go from -2 to 1. 4 minus 2x minus 2x squared dx, plus, to simplify further, 1 to 2, 2x squared minus 4 plus 2x dx. And this will give us 4x minus 2x squared divided by 2, which is basically x squared, minus 2x 3 from -2 to 1, plus with 2 over 3 x cubed minus 4x plus x squared from 1 to 2. And this will yield you the answer 9 plus 11 over 3, which will give you the final answer of 11 over 3 plus 9, which is 38 over 3. And this will be your final area under the curve. And that's it for this video.